summarizing what we have learned about the green hydrogen space and energy transition in 6 key insights is that blue hydrogen will mainly be adopted by incumbent users of hydrogen, such as refineries and ammonia manufacturers. We see that a lot of this is going to be driven by adding carbon capture and sequestration capabilities in the same facilities. Also in the US, we see that it will mainly be driven by ammonia users. So talking about green hydrogen supply, based on announcements, we see that it will likely surpass blue hydrogen by 2030. As we can see on the left, we see that over about 95% of upcoming hydrogen capacity is going to be green hydrogen, mainly dominated by PEM and alkaline technologies. And on the right, we see that it will be mainly what we see in 2022. We see that the majority of the plants today, less than 0.1% is only operational, while majority is concept or in feasibility study stages. So talking about the green hydrogen value chain, it's still in its nascency, it is still developing. And on the left, we see some of the key value chain stages, wherein we see that the first come the component suppliers, which could be the membrane electrode assemblies, or it could be the cathodes and the anodes that go into the electrolyzers. The second comes the manufacturing OEMs. We have Nel on the panel today, and we have we also have MAN today, who recently made an acquisition and acquired HTech Solutions. So these are some of the OEMs. Then we look at some green hydrogen producers, which includes Shell, Linde, and such. And then finally, we see that there are some green hydrogen consumers who already started using some green hydrogen that is being produced in refueling or in their ammonia or urea productions. So talking about global electrolyzer manufacturing capacity, we see that based on the plans and based on press releases that in 2030, we see about 48 gigawatts of electrolyzer manufacturing capabilities compared to about only 3 gigawatts today. So talking about the complex value chain, we see that the complex electrolyzer value chain is going to be highly constrained. It's mainly due to the supply of precious metals. We see very little iridium capacity today, and that is one of the major bottlenecks, as well as engineered polymers, catalysts, and other. Ultimately, if we talk about recycling and the metals recovery value chain, that's still developing, and these are some of the bottlenecks that will have to be addressed before it picks up. So PEM versus alkaline, we see that a lot of end users that need it to be small scale, or they need hydrogen which with varying loads, will prefer PEM. Also, if we look at the efficiency, physical footprint, and overall environmental friendliness, we see that PEM has an advantage over alkaline. If we compare the maximum pressure at which we need to operate certain existing applications of green hydrogen versus the new upcoming applications, we see that personal vehicle fueling, passenger cars, and heavy-duty vehicles is going to be much higher than a typical ammonia refining operations. So these are some of the key challenges that will have to be addressed when we try to scale these technologies up. So there are some key technical goals in developing PEM electrolyzers, which will in turn develop the supply chain. We look at the key goals, which is decreasing the amount of precious metals that needed, as well as trying to increase the operating temperatures and pressure. Like we mentioned, some of the upcoming applications are going to need high temperature and pressure operability. The other two are improving the power density of a single cell, which will ultimately result in less material being needed, and some of the better or best practices in terms of membrane electrode assembly fabrication. So we look at the second 2 points are at a much higher commercial readiness than compared to the first two, which is where we see most of the R&D efforts being put into. So to summarize, we see that blue hydrogen demand is going to be mainly driven by incumbents such as ammonia and refining. Secondly, when we talk about green hydrogen, we see that it likely surpass the blue hydrogen capacity by 2030. We see that the green hydrogen supply chain is still in its nascency. And there are, when we compare PEM versus alkaline, there are very specific applications where one would be preferred compared to the other. And the key technical goals that PEM electrolyzer manufacturers are trying to address will develop the supply chain. But obviously, we have the panel here to throw a lot more light and detail on what we just discussed. So.